Hi, welcome back. We're still in graph and system of equations, and we did look at these briefly in the last video, and we're going to look at them a whole lot closer now. We said that one of the solutions you can have is exactly one solution. It's consistent and independent. And if we look at these two equations, y equals negative 2x minus 5 and y equals x minus 5, if we graph these on the same coordinate plane, this one's positive, has a y-intercept of negative 0, negative 5, and it goes on a positive slope. The y equals 2x minus 5 has the y-intercept of 0, negative 5, and it has a negative slope. And we see that they intersect at the point 0, negative 5, which is their y-intercept. It will not always be at a y-intercept. It could be another point on a graph. And if we take that point and we plug it into both equations, on this one we got negative 5 equals negative 5, which is true. Same thing on this one, negative 5 equals negative 5. So that solution is true. That is one way to check to see that this point is the correct point, is by plugging it into both equations and seeing if it makes it both true. Another one is the infinite number of solutions. It's consistent, independent. So we have two equations here. Y equals negative 2x minus 3 and 6x plus 3y equals negative 9. The first thing you need to do is convert both of these into the y-intercept form. So we subtract 6x from both sides because this one is in standard form. If you need to go back and review this, we do have the videos on this. So we subtract 6x and we get 3y equals negative 6x minus 9. Divide by 3, each term has to be divided by 3, and we get y equals negative 2x minus 3. These are the exact same equations. They're going to lie on top of each other. So they're going to share every single solution, and there's an infinite number of solutions that they share. Now you know why they're dependent. They have to lie on top of each other. Our last one was no solution. So we both have these in standard form. If we convert these into y-intercept form, we get y equals 2x plus 3. And this one is y equals 2x minus 3. As you can see, they have the same slope of 2, but they have different y-intercepts. This one's positive 1, and this one's negative 3. Therefore, they will lie on the same plane together, but never cross because they are parallel lines. These will share no solutions because of that. Once you see the parallel lines, you know that there's no solutions. This is extra credit. Graph and determine the number of solutions. You have two different problems here. If you do this and turn them in, you'll get extra credit for this unit. We're going to go into our next unit, which is substitution for a system of equations, and I will see you then.